my ears are too. Are you getting sound? Okay, perfect. All right. So by day I work as a security engineer at a big Fortune 500 company. I don't use PowerShell that much in my job. Most of the code and automation workflows we write are in Python. But I still use PowerShell every day because it's an extremely useful tool, right? I have like a programmatic task of some sort that I want to solve. I just pop up PowerShell.exe or pwsh.exe if I want some PowerShell 7 features. And then I sort of just type my code in on the command line, right? So I still frequently use PowerShell, and I also use a lot of my free time helping other people sort of upskill on PowerShell. Some of you might have seen my face or my name on the Q&A platform known as Stack Overflow, where I've answered, I think we're approaching 4,200 PowerShell answers at this point over the last 10 years. I love explaining how PowerShell works to people. Having been given the moniker Posh Explainer, I take that not as an insult, but as a positive. I'm also an occasional language contributor. I've contributed a bunch of improvements to the PS type API in PowerShell that allows you to have sort of more coherent inheritance semantics when you define PowerShell classes. If you're interested in PowerShell classes, you're probably in the wrong room because Stefan is talking about PowerShell classes in the next room. So hopefully that'll be captured on the live stream. What of my contributions to the language are relevant to this talk today is I've also contributed design for a couple of improvements to both the split and replace operators, both of which are what we might call PowerShell RegEx operators. Finally, I'm also a member of the engine working group. So whenever we get feature requests or issues on GitHub for PowerShell that touch around sort of the language infrastructure or the runtime engine in PowerShell, I'm part of the group that tries and evaluates these issues and tries to sort of figure out where do we take the language or at least the runtime engine. Who are you? The intended audience for this is PowerShell users who are interested in RegEx. Maybe you already have a lot of experience, maybe you have a little bit of experience, but you have an idea that maybe you could sort of leverage RegEx to solve more problems more efficiently or with more concise code, right? Quick disclaimer, again, this is not an introduction to RegEx talk, right? If you have no idea what regular expressions is, you might become a little wiser after this talk, but some of it might be a little over your head. And I also want to mention that like any other skill, mastery of RegEx requires practice, right? Nobody's going to become an expert or a master without putting in their 10,000 hours or whatever philosophical bent you subscribe to in education, right? You need to practice these skills in order for them to sort of become natural, right? A lot of people say that RegEx is terrible, it's unreadable, I don't know how to figure it out, it breaks my brain, right? And I sort of understand that, so in this talk I'm going to talk a little bit about how we can maybe think about RegEx patterns so that isn't the case, right? So on the agenda for today, we're going to talk very quickly about RegEx in PowerShell. What are the building blocks that we can use to interact with or apply regular expressions in our scripts? Then we're going to talk a little bit about thinking in RegEx, thinking about these patterns, making sure that they don't break our brains when we try to interpret them or use them, right? Then we're going to talk about something I haven't talked about before, which is RegEx options. The RegEx engine in .NET, which is what is exposed in PowerShell, has a bunch of flags or options that we can use to modify the runtime behavior of the RegEx engine. And so there's sort of a subset of that part of the API that I want to look at. And then I'm going to tell you a story at the end. This is not going to be a very demo-heavy talk. In fact, I haven't prepared a single demo. If anyone wants to see something or wants to see me demo something or I talk about something and they're like, that doesn't make sense until I see it in PowerShell, please raise your hand and say so, and I will do that, right? But we will also make some time during the Q&A. So if you pick up anything along the way and you're like, I'd like a more concise example of that, feel free to save it for the Q&A. Okay? All right. What is RegEx? Well, RegEx, sort of broadly speaking, in the context of programming languages, usually covers a set of tools and some grammar, right? A language specification of some sort, to primarily interrogate and manipulate the contents of strings. We also broadly refer to them as pattern matching engines because the sort of modern implementation of these regex engines in programming language have diverted so far from the mathematical meaning of what a regular expression is that maybe we shouldn't be calling them that anymore. But regex has sort of become part of sort of IT culture because of its prevalence. And so we still use the term regex when we're talking about these pattern matching engines. I also want to be very clear that regex is in no way black magic, right? And regex is also not impossible to master, even though it may seem that there's sort of a high bar to entry, or again, these patterns look weird and break your brain. Regex in PowerShell specifically is exposed by a number of sort of primitive building blocks that we can use. Some of you might be familiar with the two comparison operators, match and its inverse, not match. Anyone here who has never used match or not match? Okay, so we're all familiar. Okay, so the match and not match operators is a string comparison operator, just like the EQ or the like operator, right? On the left-hand side, we would have a string value, and then on the right-hand side of the match or not match operator, we provide a regular expression pattern. And then the output of the operation is either going to be true or false, right? Did it match or did it not match, or so on. We can't talk about the match and not match operators without talking about the special automatic variable $matches. Every time dash match succeeds or dash not match fails, meaning that it actually did match something in the first place, PowerShell is going to take the results of the underlying regex operation and push them into a table that it stores in $matches. And so maybe we can, if I can switch mode here. So I'm just going to come up with the most basic example here, right? As I said, on the left-hand side, we have a string value, hello, world, exclamation mark. And the simplest regex pattern to match that is simply the string itself, right? And so the string hello world is also a valid regex pattern. I'm just going to, is this easier to see maybe? Okay, good. So the string hello world is also a valid regex pattern, right? The H is going to match a literal H in the original string. The E is going to match the E, and so on and so on. None of the characters in this string, including the comma and the exclamation mark, on their own has any special meaning in regex, right? They're just text characters. So if I run this snippet, right, sure enough, it tells us that it satisfied the pattern, right? We had a match. What's maybe a little more interesting in relation to matches is that if we have a look, you'll see that it now contains what appears to be like a hash table or dictionary, right? There's a single entry with the key 0 and then the whole string that we matched. Okay, maybe that's not so interesting because we already knew that, right? We already knew what the input string is. But where it really gets interesting is that if we start using something like a grouping construct in .NET usually starts with parentheses, right? So what we're going to say here is that actually we'll consume anything except for the exclamation mark. We can use a so-called character class for that. And so we say anything but the exclamation mark, and we want multiple characters. And what the grouping construct, this grouping construct here, without any sort of qualifying marks, is going to do is it's going to capture whatever was matched by this expression. Okay, what does that mean to capture? Well, let's have a look. Look at matches again. And all of a sudden we see that there's an extra entry in this table right here. So we've actually been able to extract the exact value that was followed by hello, right? And so this means that we can now input any variable part of the string, right? And all of a sudden the matches variable will hold that value, right? And so this might be very interesting if you have like a large set of text, right? An array of strings, maybe the line from a file or something like that. And you want to extract text from some of these lines, but you're not interested in the entire line, right? So then you could use a pattern like this, right? So you would take your array, pipe it to something like for each object, and then you simply do if the input matches your pattern, assuming pattern contains regex pattern with a single capture group, we would then be able to do matches 1. Now, why am I guarding this behind an if statement? Well, the reason for this is that if the pattern doesn't match the input string, PowerShell is not going to do anything about the matches variable, meaning that if I start inspecting what's in matches after it failed to match something, I'm going to get the previous result, right? One variation of this pattern that I've seen a couple times is this. Where you sort of split it up into 2 pipeline elements. This incidentally works in PowerShell because by default, PowerShell doesn't do any output buffering in between pipelines. But if anything happens that would sort of disrupt the flow of the pipeline, this is not going to work anymore. You sort of disjointed the relationship between whether it matched and then what's actually in matches. So again, this works 99% of the time, but I would sort of strongly discourage it. All right. No. Okay, here we go. In addition to the 2 comparison operators, match and not match, we have 2 sort of string-specific operators, dash replace and dash split. As the names imply, they do 2 different things. Replace replaces contents in line. So you might have a string containing some structured text, right? And you want to flip around the order of 2 elements or 2 tokens in your text. The replace operator is great for doing that because it's going to take a single string as input and output a single string, right? So there's always a one-to-one relationship between the input and output for the replace operator. So it works really well. It's sort of a little bit like the pipeline, right? You sort of just munch a bunch of stuff in on one end, and then you get the exact same amount out on the other end. The dash split operator, as the name implies, is used for string splitting. Some of you might be aware of the built-in string methods for this. So if you do something like, if you take a string literal and then do dot split, it'll allow you to split a string based on a verbatim substring pattern, right? So let's say we want to split something by comma. We would take the string value or the variable that holds the string value and do dot split and then a literal comma. And that would work. It would swallow the comma and it would give us everything in between. But sometimes you want to split on nothing. For example, maybe there's like an empty space in your string where you sort of just want to split it into 2. And for this, the split operator might be really useful. I'll bring that back up in the Q&A. I have a couple of good examples of that. Finally, we have the switch control flow statement in PowerShell. How many people here are familiar with the switch statement? Okay, so about half the room feels comfortable with switches. As you might know, the switch statement has a bunch of mode switches. Normally it works in wildcard mode, meaning that if you give a wildcard string pattern as a case in a switch statement, it'll evaluate it as such. What not everyone knows is that the switch statement also has a regex flag that you can use to then default to regex matching instead of exact or wildcard matching. And so again, this might be useful if you're implementing parsing routines. One thing that's a little bit special about the switch statement in PowerShell in comparison to other languages is that it can take enumerable values, right? So you can pass an entire array to a single switch statement in one go, and it'll evaluate it as if you were sort of doing a for each loop over it. Finally, we have the select string commandlet. The select string commandlet is more useful when you're trying to interrogate string contents on disk, right? So if you have a bunch of files, you maybe have a regex pattern that you want to see whether some of these files contain a keyword or something like that. Taking all of your file info objects, piping them to select string is usually the easiest way to do this. Finally, for sort of the black belts or the people who want to do some things outside of what these existing operators, the switch statement or the select string commandlet can give to you, we have a type accelerator in PowerShell, which is just regex, which resolves to the RegEx class that sort of implements the whole RegEx engine API in .NET. And so if you ever find yourself sort of like constrained by what the operators can do, right, the information you're getting back, maybe it might be worth looking into the RegEx class, sort of bypassing PowerShell's own nice syntax, and then sort of like interacting with the API directly. For all of these PowerShell build-ins, I have a couple of. There we go. One thing that's useful to know here, if you've used PowerShell for a while, this is not going to be a surprise to you, but all regex primitives in PowerShell default to apply regex option ignore case, meaning that every comparison is case insensitive, just the same way all the other comparison operators in PowerShell are case insensitive by default. Just like any other comparison operator, all the operators we saw before, replace, split, match, not match, also support a case-sensitive version, right? So you prefix it with a C, so you do a -C replace instead of -replace, and all of a sudden you get case-sensitive matching instead, right? It's going to remove this ignore case option. The second point might not be relevant to everyone. If you're working in an environment that is using English language localization, or perhaps even sort of like default English US localization, you probably would never notice this, but I use Danish as the default localization on my computer. And we have a bunch of letters in Danish that you don't have in English. And when you enable, when you do case-insensitive matching in .NET's regex engine, it's going to try to figure out whether a lowercase letter is equivalent to some uppercase letter, and you can have some unexpected results where the regex engine is basically going, it's like, oh, this letter over the lowercase letter of this version of this letter over here is actually the uppercase over here, even though it's not the case. I've run into this a couple of times. I think there's a couple of like localization IDs. Turkish springs out as having two different kinds of I's. So like equivalence between a lowercase and uppercase I might give you some unexpected results. So again, 9 out of 10 people might not need to know this, but if you run into a situation where all of a sudden you're passing in text input that has characters outside of the ASCII range, right? So you have Unicode characters, weird diacritics, whatever it is, then it might be worth keeping in mind that by default it applies your thread culture. All right, thinking in regex. We're not going to dig too deep into this, but I want you to realize that regex is not just like a simple substring matching algorithm, right? Regex is a programming language unto itself. And what happens every time you invoke one of these operators, the match operator, the replace operator, the split operator, whatever, the regex pattern that you pass as the right-hand side operand is going to get passed by the regex API, right? It's going to take it apart and say like, does this fit with the grammar of this regex flavor? Once it's been passed, it's going to compile basically a little bit like an AST, an abstract syntax tree, right? It's going to sort of create a structured program around the source code that the pattern you just passed in actually was. By default, the regex.NET engine creates this sort of pass tree out of your pattern, and then it runs a runtime interpreter, much like PowerShell or Perl or Bash, all of these languages where we sort of, most of the time, we're sort of just processing one line or one instruction at a time. There is an option in .NET regex to compile regex patterns to actual code, right, to actual intermediate language .NET code that's executable. We're going to talk later about why that is probably not something you ever need. But I think it's really good to have in mind that, again, regex, not just simple substring matching, we're actually using sort of this language with the weird patterns to create new programs that are getting JIT compiled at runtime. And this also means that there are a couple of primitives or patterns in regex that actually are sort of equivalent to control flow statements that we might find in real programming languages, right? The first, this if-else example, also known as the greatest regex trick in the world. Basically, the idea is that if you want to capture ABC, but you want to avoid capture substrings that contains ABC but with some other stuff around, then you just match those before trying to match the thing you're trying to capture. This is equivalent to an if-else statement in an actual programming language, right? Again, we also have while loops. This might seem sort of silly, but the plus quantifier after /w at the end there is not that different from a while loop, right? As long as we can find a word character, we just keep consuming, keep consuming, keep consuming. Finally, we even have something equivalent to a throw statement, because .NET RegEx has heavy support for something called lookarounds. And lookarounds can be used to look for something not being there. And so in this case, we can just look for nothing not being there, and that will always fail. And so we actually sort of like have control flow in .NET RegEx. One thing that I have found to be really useful, both when sort of explaining and teaching regex, but also when I'm sort of trying to explain to myself, like what am I even doing here, is to sort of try to break down the pattern into individual components, right? So again, a regex pattern is just is also just a string, right? So if you start reading each character left to right the same way you would a sentence of text, and then try to think of the escape sequences, the grouping constructs, as sort of individual atomic components of your pattern, then you can sort of break down, start looking at them individually, describing what they might do, how they might behave, and then you can sort of individually test those against substrings in the input text that that you have. If you get stuck with this sort of thing, no worries. There's a ton of sites online where you can sort of test regex, right? You give it a pattern and then you give it some test input, and maybe it breaks down and give you an explanation, right? So regex 101, regex, or there's like a ton of these sites out there. One thing to be aware of when you're using these online tools is that most of them default to using something called PCRE. PCRE stands for Perl Compliant Regex, and as the name implies, it's sort of a C library that's implemented to mimic the pattern matching engine implemented in regex. And it is a little bit different. Every regex engine is a little bit different from each other. And it also means that PCRE is a little bit different from the .NET flavor of regex that we're using in PowerShell. So just be aware of that. I think on regex 101, there's actually a switch where you can go, I don't want PCRE mode, I want Python mode, or I want Golang mode, and I think they recently added a .NET mode as well. So if you're seeing sort of inconsistent results, you test something online and you're like, why am I not getting the same result in PowerShell? Again, remember the defaults, right? Maybe there's some ignore case interference. And then the other thing is, are you actually testing the same thing, right? Because the website might be testing against a different version or a different flavor of regex. Okay, this is very easy to say. Let's see what that actually looks like in practice. So we're going to try to think in regex. Here I have two lines. On the first line, I have sort of like a sample, very simple email address, right? We all recognize the format of an email address, right? We have like a user part on the left-hand side of an @ sign, and then we have a domain or host name on the right-hand side, right? And so if I wanted to extract the individual parts of this, because let's say I want to figure out how many users I have who signed up for my service sharing the same email domain, for example, then it might be useful to be able to describe an email address or this type of email address with a pattern, right? And so down in the second line, I have a suggested pattern that could be used to pass this particular string, or at least match this particular string, right? And so we're just going to sort of go through it step by step. This is the first atomic component, right? And you might want to say, isn't that too much? It's like, no. The square brackets describe what we call a character class, right? So it describes sort of the attributes of 0 or more characters that can be matched. And then the plus at the end is a quantifier, right? The plus itself doesn't do anything or match anything. The plus just says, I want one or more characters matching that description, right? So this first component, again, we're sort of back to the last slide. This is a while loop, right? As long as the input contains the next character that isn't an @ sign, it's just going to keep consuming that as part of that subpattern, right? And so sure enough, if we sort of unleash this, say with the match operator, for example, it would match this part leading up to the @. The next part is just a literal add, right? You'll notice following the add, there's no quantifiers or anything. So we're just looking for literal add, and sure enough, that's going to match the literal add in the pattern. The next atomic component here is, you might have seen this construction before. In RegEx, without any escape or any other context, the dot means any character. In .NET RegEx, it specifically by default means any character except for a new line, and we'll get back to that in a second. But it just means any character, right? The asterisk, the star, means 0 or more characters, right? A little bit like the +1 or more. But here it becomes optional, right? If there's nothing there, then that's fine too, right? This sub-expression can be satisfied by an empty string, basically, because that would be 0 of anything. The question mark at the end modifies the behavior of the previous component to be lazy rather than greedy. Now, what do I mean with that? Well, what I mean with that is that PowerShell or RegEx is going to try to match as much as possible by default. So when you put up a construct like, oh, I want any character 0 or more times, the sort of tendency of the RegEx engine is to say, oh, great, I'll just take the rest of the string, because that also satisfies this pattern, right? By modifying an existing quantifier with the question mark, we turn it into a lazy one, and instead the RegEx engine is going to attempt to match as little as possible. And the effect of that in this scenario is that it is going to match domain, because the next component we have in the pattern is a literal dot, and there is a literal dot, meaning that this is sort of the first place in the input string where the subpattern dot asterisk question mark can exit, right? It can exit early, and as soon as it can do that, it'll do that. Again, because the dot has a special meaning, we need to escape it with backslash, and that thus matches the literal dot in the input string. And then finally, this component right here is again a character class, anything except for a literal dot. I should note here that I don't need to escape the dot inside the character class construct. It knows that we would never use any character inside that context. And again, the plus means we want 1 or more characters, right? The tuple of domain is going to have at least 1. And then the final character here, the $, means either end of line or end of string, depending on the options. In this context, it means end of string. And given that there's no more content, right, we're at the ultimate position of the string here. That is satisfied too. Any questions? Very good. Right. I said earlier I was going to talk about something I haven't talked about publicly before, which is RegEx options, right? And we're going to have a look at two that I don't think I've ever talked about publicly, which is the explicit capture non-backtracking options. I should note that there is, again, a bunch of different options for modifying the runtime behavior of the RegEx engine. The most common being the multi-line and single-line switches. Multi-line changes the behavior of the dot to also match new lines. So if you want to capture something with like the dot asterisk pattern, and you want that to span over a new line character, use the M or multi-line option, and then all of a sudden it'll match the new line character as well. The next thing I want to mention is the single line option. Wait, no, I mixed them. Forget what I just said. The single line option turns the dot into matching new lines, so that basically you treat multiple consecutive lines as like one big line, right? Hence the name single line. Whereas the multi-line switch changes the behavior of the $sign that we saw before. So instead of just matching the end of the string, it's also going to match the end of a line. This might be useful if you're, again, passing multi-line text and you have like a keyword or an anchor or something like that, and then you want from there till the end of the string, till the end of the line rather than the end of the string. You enable multi-line mode, and all of a sudden the $sign is going to match at the new line. The two options I want to dig into a little bit today is the explicit capture option, and then a new option that was introduced in .NET 7.0. So I guess that gives us PowerShell 7.2 is the first stable release where this is possible. But there is a new option called non-backtracking, which will prevent sort of a core dynamic feature in the .NET RegEx engine that will prevent your RegEx patterns from engaging in what we might call catastrophic backtracking. This idea that sort of all these loops I described before, if you have too many while loops in your patterns, all of a sudden you sort of end up with 400,000 executions of the same pattern because it can't quite figure out what's the optimal thing. And so in .NET 7.0, first time ever, we now actually have the option to disable backtracking in the engine completely. But that also means that there are some features you can't use, and that might be useful to know about. Finally, there are three options that you don't really need to pay too much attention to. Ignore case, because you already know that as a PowerShell user, you know we always default to case insensitive anyways. The two others are compiled and ECMAScript. Why should you forget about those? Well, they sound really cool, but they don't really do anything. As I mentioned before, the compile option actually causes the regex engine to compile your regex patterns into MSIL, so like .NET bytecode. And this might be useful if you're doing like 10 million executions against a single regex pattern that's very complicated. But the overhead of compiling the pattern into MSIL rather than just interpreting it at runtime is pretty big. So usually what people find is like, oh, compiled, that must be fast. I'll try this option, and all of a sudden their script is actually twice as slow, right? Because it takes a lot of time to compile that pattern in the first place. So again, the compiled option sounds very enticing. The reality is that you'll either have no noticeable difference in 99% of cases, or you're actually going to shoot yourself in the foot by adding a bunch of overhead. The other option, ECMAScript, exploitation, JavaScript regex. We're going to get some cool new syntax or some stuff that we've seen in regex in JavaScript, but not in .NET. No, that's not the case. It's just slightly altered back reference handling, and we're not going to be talking about back reference handling in this talk anyways. But yeah, ECMAScript compile options, not as interesting as they sound. Forget about them. The option I really wanted to talk about today is the explicit capture option. As I mentioned before, I spent a lot of time in the PowerShell Discord, and sometimes people come in and they say like, oh, I'm trying to do this thing with regex, and I'm trying to extract these things, and I have this script that's like 20 lines, and there's like 15 regex operations in there, and I respond with a single regex with a bunch of capture groups that say like, oh, you can apply this once and do everything. And they're like, why do you have all of these squiggles, right? Have all of these grouping constructs that start with parentheses, question mark, dot, dot. The difference between this and a normal capture group is that normally, as I said, the parentheses, this grouping construct is going to push whatever was matched onto what's known as the capture stack so that we can reference it later, right? It's going to get pushed into the $matches variable. But if I don't want that, right, if I just need a grouping construct because it's something else I'm doing in my pattern and I need to sort of bind multiple elements together, but I don't want to capture them regardless of what the value is, what I can do is I can use a non-capturing group construct, which is parentheses, question mark, colon, and then whatever the sub-expression was in there. As soon as you turn on the explicit captures option, the grouping construct without the question mark is going to start behaving like it. So now you can use this super simple grouping construct in your pattern without, the idea is basically to make the patterns more readable, right? To make sure that you can still actually capture stuff, you're required to use something called explicit capture groups, and so that would have the format down here, right? Open parentheses, question mark, and then greater than, less than brackets, right? And then either a name or a number in between to sort of declare the capture group you want to push it into. Again, when to use this, if you have a long or complicated pattern with multiple groupings, but you're actually only interested in capturing like one or two, and you want to avoid this mess of like having these clumsy non-capturing groups all over the place, this might actually be really useful. The other option, as I said, non-backtracking, this is a newly introduced feature in .NET 7. The regex engine in .NET has sort of gotten an overhaul over the last few stable releases of .NET. And one of the features that people have been asking for forever is the ability to disable this very useful but also potentially very resource-consuming feature called backtracking. And so if you invoke one of the RegEx methods with the non-backtracking RegEx option, it disables backtracking and gives you sort of like nice, predictable linear time execution of your RegEx operations. But it also disables any feature that in any way requires on what backtracking provides in .NET in the first place. And so that means atomic grouping constructs, back references in the pattern, balancing groups, conditionals, lookarounds, and /g. Anyone here familiar with /g? It's like a special back reference construct in .NET. Okay, this is a really fun one. We'll take that up during the Q&A. But basically, yeah, okay, so if you're afraid that you're going to get some untrusted input that might cause your regex to sort of go haywire and consume a lot of resources on your machine, disabling backtracking might be an option, but make sure that you test your patterns with non-backtracking option turned on against all of your expected input, because you might also end up in situations where things that usually match because of the backtracking no longer works, right? All right, I've been talking about this backtracking thing. Why am I talking about this? Well, I'm talking about this because I want to tell a story. Some of you have heard it before, some of you have not, but as I mentioned during the introduction, I am a contributor on the Q&A side node as Stack Overflow, and a couple of years ago, they had a spectacular outage where the entire site was completely unusable. It wasn't down, but it was just unresponsive for over half an hour. And a couple of days later, they published this post-mortem, and a couple of things stood out, right? Especially the sentence in the middle here that said, the direct cause was a malformed post that caused one of our regular expressions to consume high CPU on our web servers. And so you might ask yourself, what are you even talking about, right? Like, it's just a web page. You just need to show a couple of links. And like, why is regex going crazy on your front page? Well, the offending regex pattern was this. It may look a little intimidating, but it's actually very simple. We have sort of the pipe symbol in the middle here. The pipe symbol in regex is known as the alternating operator. And it's a little bit like a logical OR, right? Either look for this or look for that. And on the left-hand side of the alternation construct, we have the caret symbol, which in this context means start of string, right? So the position 0 in the input string. Then we have one of these character classes consisting of two elements, /s, which is all whitespace characters, and then /u200c, which is a formatting Unicode character, right? It's not important what it is, but just know that we have this fairly simple pattern, right? It's only going to match a couple of types of characters at the start or at the end of the string. Now, what is the purpose of having a regex like this on the front page of like a social media or QA site? Well, the idea is that all of their input is user submitted, right? So I can create a post in Stack Overflow, and nobody's really stopping me from like breaking all the formatting rules that I'm supposed to follow. And so I could submit a post that was just 10,000 whitespace characters and a joke, right? And so if I do that, and then on the front page you try to show a summary of that question, if you just take the first X characters of the post, you're just going to get white space, right? That means anyone browsing the site is just going to see a question title and then blank space. It's going to look like everything is broken, right? So what you want to do when you summarize these things is you want to make sure that you trim the input string so that you're not including a bunch of unnecessary white space trivia in the output. And so, okay, that sort of makes sense, right? They really just want to like trim the edges of the string so that they get like meaningful output in their summary. We could also simplify this. This might make it a little easier to think about, right? We could simplify this pattern as just saying, look for white space at the start of the string or look at some white space at the end of the string. Now, why would this cause an outage, right? Like, that doesn't make any sense. You just keep looking at white space at the start of the string, you keep looking at white space at the end of the string. Why is this a problem, right? Well, again, regex engines are complicated and they're a little bit deceptive. So when it sort of comes to sort of worst case performance implications, it doesn't really have anything to do with how long the pattern string is, and it doesn't really have to do anything to do with like how readable or complicated the pattern string looks, right? Like they all look complicated and unreadable, so like it's not a good way to qualify anyways, right? But what is actually true, and this can be a surprise to some, right? Significant performance degradations in regex depends on the length of the input strings, right? The more input we have, the more options we have for sort of exploring what options we have for matching the pattern against the input. And then it has to do with greed, right? We already talked a little bit about the fact that these two quantifiers, the asterisk for 0 or more characters and the plus for 1 or more characters, are greedy by default, right? They will attempt to match as much as possible until they can't do anything more. And so if you have if you either start nesting these patterns, or if you have a lot of them side by side with a lot of overlapping ambiguity in how you're matching the actual characters, then you end up in this race where sort of the .NET regex retries everything all the time, and this can lead to some terrifying problems. In order to better explain all this backtracking back and forth, I've come up with a simpler example and a visual aid that I call imagine your regex engine as a car. This is a car. Imagine this is our regex engine. I have here an input string, the string banana, and I have a pattern down here that describes start of string, the literal letter B, then dot asterisk, so any amount of any characters, and then the literal characters A and A followed by the end of the string. We all agree that this pattern should be satisfied by this input string, right? We should expect to see a match, right? Okay, so let's go through how the regex engine, with backtracking still enabled by default, actually goes about this. The regex engine is going to hold at least 2 cursors. One that keeps track of how far we are in matching the components of the pattern itself, and a cursor keeping track of where we are in the input, right? How far did we get along with the previous parts of the pattern? This part will be represented by the car, as you can see at the top. So start of string, okay, we're at the start of the string, all good. Next part of the pattern is the B, right? If we move the regex cursor or car to the first character, we can satisfy that easily. The pattern asks for a letter B, and we find a letter B. Okay, so good. So far, so good. Next component is the dot asterisk, right? Which is going to just match as much as possible. And so what's going to happen now is that the little car is going to move to the next character position and go meow. It's a while loop, right? It's just going to consume until it can't consume anything anymore. Now we have a problem, right? Because the next component in our pattern is an A, and the car isn't there anymore, right? Like it's driven off a cliff. In fact, the rest of the pattern, we can't do anything because there's no more input. So .NET says, well, this part of the pattern that I matched before is variable length, so maybe there's another way I can satisfy this thing. So what it'll do is it'll move back 1. And then it'll try again. Oh, I'm doing it the wrong way around here. That's why it looks so weird. So the car is going to back up to the last remember position. Nope. Still can't. There's still some more we need to match. Now we need to back up again. So backs up 1 more character. And then all of a sudden, we can satisfy this pattern, right? But did you just notice the car like having to back up like 3 times in order to satisfy this, what to a human eye looks like a fairly straightforward pattern, right? This is why you might want to engage in lazy modifiers, like making your subpatterns non-greedy. And this is also why you might want to consider turning off backtracking if you don't use any of these backtracking features. Very nice.
If you use the question mark to be lazy, there will be a also some.
There will also be some backtracking. Right, so the question here is, if I added a question mark after the asterisk here, right, to make this component no longer greedy but lazy, would there still be backtracking? And yes, there would. There wouldn't be as much backtracking, but we would have the same problem in reverse, right? Because what's going to happen then is the regex engine is going to say, if I don't need to, if it's lazy, then I'm just not going to match anything, and I'm going to move ahead to the next character, which is an A. Oh, that's fine. And then N, and then an A, and then oh wait, we don't have the end of the string here. I'm going to have to back up 2 more times again, right? So in this particular example, using a lazy modifier would have optimized it slightly, but we would still have the problem with backtracking. Again, one thing I want to mention here is don't get too sort of trucked down in using regex at any price, right? You don't have to. You could have also used like 2 wildcard patterns to check whether this starts with a B and ends with A and A, right? So again, regex is very useful, very flexible, but it's not the sort of end all and be all, right? And you should never be embarrassed that you pick another simpler tool in place of regex. In fact, you should applaud yourself. All right. To sort of wrap up what we've been talking about, regex facilities are plentiful in PowerShell and in .NET in general. Regex can look sort of simple on the surface, but don't get fooled, right? You're literally programming a computer inside of your computer. Please remember that. And with that, I'm just going to leave you with my core advice. Please go practice. Any questions? Yes?
Probably a small thing. All the special characters in .NET, it might be hard to remember sometimes whether you should escape particular character.
Yes.
And there is this helpful .NET method called escape. It's a static method on the RegEx store, which I often use to help me with that one.
That is absolutely correct. Let's just get an example of that, right? So let's say I have a string that contains something that would have otherwise been interpreted as a special construct or an escape sequence in regex, right? So let's say I have a document named like document123.pdf, right? Why would you name your document like this? I don't know, but some people might, right? So in this case, if I start doing something like match document, is this going to match or not? No, it is not. And it is exactly because of this, right? Regex is going to interpret this part of the pattern as a character class, and it's going to look for exactly one of either 1, 2, or 3. So if I change back to this, it would have worked, right? Or the other way around, if I change my pattern to do this, it still won't work because we also need to match the literal square brackets, right? As was just suggested, there is a simple way to get around this, right? If you have a literal string that you suspect or that you don't control, and that you suspect it might contain anything like this, what you'll want to do is use the static regex replace method. And so, again, the regex class here. This is extremely important when you're, again, sort of constructing patterns from untrusted user input. You don't want to take people's input as just patterns, right? If you're given input for match this term or whatever, you want to make sure you escape it before you embed it into your own patterns. Yeah. I have a gift for you because that was an excellent suggestion. I have more cookies in my bag, so if anyone else has great questions or great suggestions, please, now is the time to raise them.
By the way, I didn't know it works with strings. I thought it worked only with characters. So
the escape method? Oh, right, no, it takes a literal string, right, and basically just produces what would be the literal pattern, right? So again, if I paste this down here, we can see that the output of it is, it also takes into account the fact that regex has an option that ignores all white space. This is very useful if you have like very complicated patterns and you want to like put inline comments or something like that, or you sort of want to break it out to make it more usable. Using the ignore pattern whitespace option will allow you to do that, but then you need to make sure that all the literal whitespace characters that you actually want matches for, that's actually part of the pattern, they need to be escaped to, and this is what regex escape takes into account here. But yeah, excellent suggestion. Any other questions? All right, well, thank you very much.